Welcome to our project Fresh Water from Ships, where we aim to revolutionize clean water delivery. By harnessing our ocean and landside network, we produce and transport fresh drinking water to the most remote regions on Earth. Our innovative approach ensures the lowest carbon footprint, making sustainable water access a global reality. This is our team in Maersk, a group of volunteers who decided to pull in our resources together. As you can see, we have people from various functions in the company, from service fulfillment, project machinery, energy transition, and product enablement. These volunteers came together because they believe that we can build a global network of water delivery and assist organizations that need clean drinking water in terms of crisis. I will go through the process of what we intend to achieve in this project. So our process is about not only generating, storing, but also delivering fresh water using our ocean and landside network. First, we load an empty container on a container ship. Once this container is loaded on board a vessel, it has to be loaded at the correct spot in order for the piping system to reach this freshwater tank container. Once the vessel starts its journey and the engine is running, we have a piece of equipment on board called the freshwater generator. This freshwater generator uses the residual heat, the waste heat that comes from the engine to convert seawater into fresh water. And it can, depending upon the type of generator installed, the average freshwater generators can produce anywhere between 18 to 25 tons of water a day. But the vessels only use 8 to 9 tons a day, so the excess water gets stored in tanks, and we intend to partly put this excess into this tank container. So in effect, as the ships are moving, we can keep producing water. Now that the tank container is filled with clean drinking water, 25,000 liters of it, it's ready to be discharged. Once it reaches port with efficient cargo operations, this tank container is discharged into the terminal, and then the terminal keeps the container and uses this water for its own resources. This water has been tested by WHO standards, and the previous testing proves that the water is fit for use and is of high quality with low TDS. And at the moment, we are planning to install water filtration systems as well as an additional measure to ensure that the water is drinkable when it's landed into the terminal. The terminals can use this water to fill up their own reservoirs or their own tanks within the terminal, or they can even use it for other services, for example, reefer maintenance or cargo care, and then thereby reducing their water consumption as a domino effect and not relying on the resources within the port. Over time, we want to build a smooth, easy to use network where water delivery, water production, water delivery, water storage becomes so smooth that the terminals can reduce their own water consumption on a global network, and the water that is being made is of low carbon footprint. Now, what are the milestones we have achieved so far through this project? Project started back in 2020 when three ex-seafarers came up with this idea about how we can utilize this excess fresh water that we make on board. In 2021, we were part of the Maersk hackathon where our idea was recognized and we were provided support and motivation from the senior leaders within the company. After different talks with different terminals, different resources, Triton, a very famous, one of the biggest container leasing companies in the world, decided to collaborate with us and gave us our first freshwater tank container. In 2024, we managed to load this tank container on our vessel, which was Maersk Technica, on a journey from TPP to Colombo. And in this journey, as soon as the container was loaded and the vessel departed the port in Malaysia, within 5 hours, the vessel managed to fill this tank container with 25,000 liters of water. Then on March 4th, this tank container was loaded back on board an other sister vessel called Maersk Savannah. And this tank container would then be taken on a journey to Salalah. And in Salalah, we will deliver this 25,000 liters of water. By the end of April 2024, we intend to participate in different water programs and grants that are available so that we can grow this project and build a global network of water production of low carbon footprint delivery as well. In December 2024, our aim is to seamlessly build this network on a global scale. And from 2025 onwards, we plan to liaise with the International Maritime Organization to recognize this support service built by Maersk Line's freshwater production on board so that in case of crisis management, in case of human aid, wherever there is a water shortage, they can view or look towards the shipping industry to provide this clean drinking water. Now, how is freshwater production done on board? A lot of people who are not aware of this process are always confused as to how is this water made on board. So I'd like to share a by Wärtsilä on how fresh water is made on board. So here is a typical cargo vessel which has a single stage desalination freshwater generator, which is normally available on container ships as well. As you can see, there is a running engine there and there is a cooling medium. So right next to the engine, what you see is a freshwater generator. So the cooling medium which cools the engine goes into the freshwater generator, basically taking the heat from the engine and transferring it to this single stage freshwater generator. So while the medium is going in, the generator has a pump which takes in seawater that is taken from the ocean and it fills up the condenser. Then this in the second stage, it goes out and then part of this water is used to drive an air ejector. This air ejector is used to create a vacuum inside the freshwater generator because in a vacuum, the boiling point of the water goes down between 70 to 80 degrees Celsius. Now you have the heating medium, that is the water with heat transferred from the engine brought in into the system, and it slowly fills up the heat exchanger in the evaporator part of the freshwater generator. Now, as you see, as the seawater enters the heat exchanger, the heat is transferred from the heating medium into the seawater. And as the heat is transferred, the water evaporates, the salt is deposited below as brine. It goes through a demister into the condenser section, where now it cools down inside the heat exchanger on the top, which is also cooled by the seawater system from the ocean. And once it condenses, what we get out of it is clean water, which is distilled water. This distilled water then goes into a onboard tanks. It can be used for boilers, it can be used for drinking on board, it is used for the sanitation and other services as well. So depending on the type of vessel, the water system, the distilled water is stored separately, while water for sanitation goes through another filtration system to be loaded on board. So we'd like to thank Wärtsilä for sharing this video. Now, So now that we've understood how low carbon footprint fresh water is made on board by utilizing the heat of the engine, we wish to implement a network in order to optimize how we deliver the water from the terminals that we have on a global scale. As you can see from this map, we started our journey from Shanghai where the tank container was made and we brought it on board a vessel to Tanjung Pelepas in Malaysia. From here, the first ship, as we discussed, Maersk Technica, delivered clean water to the port of Colombo. At the port of Colombo, the SAGT terminal participated with us to inaugurate our first pilot project. From there, we took it to Salalah, where in the APMT terminals in Salalah were very happy to join with us on this pilot program. The water was delivered on board Maersk Savannah, and the Salalah terminal used this water for their own services within the terminal. From there, we plan to bring it to JNPT in India. It's on its journey out there on Maersk Strassland, and the tank container was filled on May 16th on board the vessel, and it should reach the terminal on May 26th. And that would conclude the third pilot project. Effectively, we have created 75,000 liters of clean drinking water using the waste heat of engines from our ship. Now, as we're going to build on this project, we are focusing on how we can create a network of routes with places that are in demand or in need of water. From there, we plan to focus on vessels that are on a route towards Europe, and hopefully we can reach Africa in ports such as Tema in Ghana and also Dakar in order to build a network to reach the other regions that are having issues with access to clean drinking. So we look forward to growing and building this project with you all. Please have a look at the comments and reach out to us if you have any doubts or questions. And wish us luck. Thank you.